Hello everyone, this is Rashaka Janjarla. I'm an educator in Unacademy. You can follow me on Unacademy Learning Hub where you can find mother courses as well. In this lecture, I'm going to discuss about the load-life relationships of rolling contact bearings. And please rate, review and share the video and also subscribe to Unacademy YouTube channel. Welcome again to load-life relationships of the ball bearings, and in this lecture we are going to solve an example problem which is based on these relationships. The relation between the dynamic load carrying capacity, the equivalent load, and the bearing life is given by L10 equals to C by P to the power of P, where L10 is the rated bearing life in million revolutions and C is the dynamic load carrying capacity, and it has the units newtons, and the value of P, which is a constant, given by P equals to 3 for ball bearings. So for all ball bearings we have to use P equals to 3, and for all roller bearings we have to use P as 10 by 3. So this is the relation between the dynamic load carrying capacity and the equivalent load and the bearing life, okay, and given by this expression. Next, on rearranging the equation we have got and solving for C, which is the dynamic load carrying capacity of the ball bearing, given by C equals to P into L10 to the power of 1 by P. So we knew that the value of P for all types of ball bearings 3, right? Therefore on substituting the value of 3 we get C equals to P into L10 to the power of 1 by 3, and for all roller bearings we have the value of P equals to 10 by 3, and on substituting this value here we have got for all roller bearings C equals to P into L10 to the power of 0.3. So we have the relation between the life in billion revolutions and the life in working hours is given by L10 equals to 60 NL10H by 10 to the power of 6. So in most of the applications or in most of the example problems we will get the value of the life in working hours only. So we can calculate the value of any bearing in hours, right? So the relation between the life of the bearing in million revolutions and the working hours will be given here. L10 is the life of the bearing in million revolutions, and L10H is the life of the bearing in working hours. So if they give the value of the life of the bearing in working hours, we can convert this value into the revolutions, the minimum revolutions value, given with the help of this relation, where L10 equals to 60 n into L10H by 10 to the power of 6, where L10H is the rated bearing life in hours and n is the speed of rotation of the bearing. So these relations are very important in calculating the values of the dynamic load and the equivalent load and the bearing life of the rolling contact bearings, and also the values of the life of the bearing in working hours and also in minimum revolutions units. So with the help of an example problem we are going to apply these conditions or the relations that I have defined here. So here we have the example problem. In a particular application, the radial load acting on the bearing is 5 kilonewtons and the expected life for 90% of the bearing is 8000 hours. So see here, the life of the bearings, 90% of the bearings will experience 8000 hours, right? Therefore this is the definition of the rating life of the ball bearings, where 90% of the ball bearings in that group will have the life. Here the life is 8000 hours. This will be rated life, and we have to calculate the dynamic load carrying capacity C of the bearing when the shaft rotates at 1450 rpm. This is 1450, okay? So given in the problem we have Fr, the radial load acting on the bearing, 5 kilonewtons, and L10H. Here the life of the bearings in hours, that's why we have the value of L as L10H, where L10 is the life of the bearing in hours and it is equal to 8000 hours here. So where we have the value of N, the rotations of the shaft, it is given in rotations per minute. So bearing life of the ball bearing, here we have the formula between the relation between L10 and L10H, right, which is given by L10 equals to 60 into N into L10H by 10 to the power of 6, where L10 is the life of the ball bearing in hours and L10 is the life of the bearing in the million revolutions, right? So on substituting the values given in the problem we can get L10 equals to 60 into 1450 into 8000 by 10 to the power of 6. That will give us the value of the bearing life L10 as 696 million revolutions. This is very heavy value for this ball bearing, and it is 696 million revolutions. Okay, and next we have to calculate the dynamic load carrying capacity with the help of the value of L10, which is the bearing life of the rolling contact bearings in million revolutions. Okay, so in the relation between C, P and L10, C and P, we have the value of L, the life of the bearing in million revolutions, right? That's why we have found the value of L10 from this relation, where we have used the value of L10H. So if we get the value of L, the life of the bearing in working hours, we have to convert it into the life of the bearing into million revolutions. Then we can use the value of the bearing life in this equation for the calculation of the dynamic load capacity of the ball bearing. Okay, so since the bearing is subjected to purely radial load, right, therefore the value of load acting on the ball bearing will be equals to P, that is equals to Fr, where the subscript shows us the radial load, and it is equals to 5000 newtons. Okay, so we have the value of P 5000 newtons, and from the relation we have C equals to P into L10 to the power of 1 by 3, right? That is equals to 5000 into 696 to the power of 1 by 3. So on solving this, on calculating this value, we can get the value of the dynamic load carrying capacity of the ball bearing when it has the life of the 696 million revolutions will be C equals to 44,310.48 newtons. So this is the value of the dynamic load carrying capacity of the ball bearing. So here we have simply followed the instruction. Here in this relation we have the relation between C and L10, where L10 is in million revolutions, right? That's why we have derived the value of L, the life of the bearings, from L10H, the life of the bearings in hours. So for the calculation of C, the dynamic load carrying capacity, we have calculated the value of L10 in million revolutions. Okay, so with this relation we have found the million revolutions value of L10. With the help of that only we have got the value of C with the relation between C, P and L10. Okay, so we can't find the value of C with the help of the value L10H. That's why we have converted it into L10, which has the units million revolutions. So from this discussion we have found the value of C, that the dynamic load carrying capacity is 44,310.48 newtons. Thank you.